Question 5. This was a little bit more tricky. You had to read through this one. This is really about probability. It brings in inverse norm and normal CDF, so it's kind of a normal distribution question, but it's really playing along on probability and seeing if you can connect the normal model to how probability works back and forth with expected value. So let's kind of run through this. Here you're talking about battery life, and they tell you a few things. Number one, they tell you that it's normally distributed, or approximately normally distributed, the average of 30, and a standard deviation of 8 months. Now, this is batteries in general. This is overall. So this is parameter value. So that's mu equals and sigma equals. It's not X bar and it's not S. If you had written those, that's actually a deduction. That's not correct. We have a population value, not in my sample, but over all the batteries. That's true. Part A says that in how many months from the date of purchase is expected that 25% of the batteries will no longer work. They told us that the average batteries last about 30 months and that the standard deviation for that is 8 months. And so I'd like to know, if I were to kind of shade in that bottom, what's the number that marks off that bottom 25%? And you can see that here. I drew the picture of the curve, I labeled the center, and I used sigma equals 8 for my standard deviation. And I wanted to know, if I shaded in the bottom 25%, what number of months marks off the bottom 25% from the top 75%? And the way we do that is inverse norm, right? If I have a percentage and I want to get a number out, you're going to go backwards, and so we're going to inverse norm. In order to get credit for this question, you had to do a couple things. Number one, I had to give you this impression that I knew that it was normal, that I had the mean of 30 and a standard deviation of 8. Number two, I had to tell you I understood what the 25th percentile meant visually, or I had to write down the interval and how it was mapped out. I did this with a picture, and this is the way I've always kind of instructed you guys to do this every single question. Shade that curve in, indicating what that bottom 25% looks like. Okay, and the third part was to get the correct number, and that was 24.6 months or less. That marks off the 25th percentile. Well, that's about it for that question. Part B, suppose one customer who purchases a warranty selected at random. What's the probability that the customer select will require a replacement within 24 months of the date of purchase? Now, we know that it's less than 25%, because 25% of the people, batteries last 24.6 months, right? So what if we want to know what's the area, what's the percentage of the curve less than 24? So I didn't have to redraw the picture, but I did it anyway, just to kind of, because I wanted to shade it and I didn't want to kind of get a confusing image between these two pictures. And so I wrote down what's less than 24, right? And with a mean of 30 and a standard deviation of 8. And so obviously I'm looking for probability this time, so I'm using normal CDF. As long as you drew the picture of the curve and you showed how you calculated it, or maybe if you didn't draw the picture of the curve, you defined what each one of these values represented. Okay. If you drew the curve previously, then it automatically can transfer down to this question that you know the mean is 30 and the standard deviation is 8. So you get those correct, but you still would have had to have defined what your boundaries were, 24 and then negative infinity, or you could have used 0. As long as it was 0 or less than 0 as a barrier, because that's kind of like the natural boundary for batteries. You can't have a negative value. So you would have gotten credit. The correct answer is 0.2266. If you did those things, let me repeat that. For part B, you had to, if you did this in step 1, you didn't have to redo it, but you had to give the mean and standard deviation and let me know that it was normally distributed. So if you got that done in the first one, it satisfies it for part 2 as well. Okay, you had to give me the boundaries and how you shaded it and what probabilities you're going to find. If you drew the picture like I did here, then it satisfies it. If you label the values on the end here, if you just put the numbers down, it doesn't count. You got to tell me, like, what is that? Lower bound, upper bound, and so forth. And then the third part would be to get the actually correct value for this. Okay. Part C, this one says I have a $50 profit if somebody buys a warranty and I don't have to honor the warranty if the battery lasts longer than 24 months. 2, if they claim their warranty because their battery went bad before the 24 months was up, then I knew that I was going to have to pay, I was going to lose $150 per person that did that. This is a probability distribution, and we need to find expected value. Your key word there, if you're reading through this is what is the expected value, and they didn't even hide that. They used the exact language. And so I wrote down a probability table, the outcomes. In this case, I was looking for how much profit was going to be made per person. They're going to make $50 a person if they don't have to honor the warranty. They're going to lose $150 if they do have to honor the warranty, which means, and that's it, that there are no other options here, right? So what's the probability? Well, we already know that what percentage of people are going to need a new battery? Well, what percentage of people batteries lasted less than 24 months? Well, I found that in part B, so that's 22.66%. So I can tell you if that battery is bad, I'm going to have this situation happen. To get the other side, I just subtracted from 1. You could have used some kind of other crazy stuff with inverse norm or normal CDF, I guess, and you found it, but that was overkill. You didn't need to do that. The probabilities add up to 1 because you only have 2 options. Either the battery was bad or the battery was good. They honored the warranty or they didn't. In this case, we know how to find expected value. You're going to multiply the probability, the outcome, times the probability, and you're going to add it all together. Do that, you end up with about $4.67. I think if you rounded a little bit less than I did, you might have gotten $4.68, which is fine. I think that's what's on the key, actually. But if you use the exact value, you're going to come down to $4.67 as an expected value. In order to get credit for this piece, 2 parts had to be done. Number 1, you had to write out the probabilities attached to each of the outcomes. Now, I did it twice. I represented it in the table here. I also wrote it down in the equation. I didn't need to do both, but I did need to write down what the outcomes probabilities were, which one with what. This was just me helping me organize myself, and this was the math I did to get it right. And that's it. Qual 5 was a relatively really short question. This was a really nice one if you were confident with normal CDF and inverse norm and things like that. So hopefully that went well for you. Thanks.